All right. So, oh, we are not in the right spot. Okay, homeostasis. So, this is a pretty quick um, lecture. It's only like 10 slides or so. But homeostasis and feedback loops is what topic 5 covers. So how your body and how cells essentially regulate your things like temperature and the body's homeostasis, the equilibrium of the body. So an overview: the body must be able to monitor its internal conditions at all times, and there are some set points that your body is always trying to stay at. So, for example, temperature, your body always is optimally working at about 98.6 degrees Fahrenheit, or I think it's 37 degrees Celsius, whichever one you want to use. But set points are values for various physiological conditions that the body tries to maintain. So, temperature is a really good example of that. And things like cholesterol or blood glucose or whatever else you want to talk about is the same. So the set point has a normal range for which it can fluctuate. So like I said, an example is body temperature. The set point is 98.6 degrees Fahrenheit. And the normal range will be 97 to about 99 degrees Fahrenheit. So it's not super concerning if you have a slightly elevated temperature, which is why, for example, when COVID was kind of prevalent, the temperature that was more alarming was like 100.4, right? That's when you weren't like allowed into the school or into I don't know, Universal or something. All right, so homeostasis is a state of relatively stable internal conditions, and organisms will detect and respond to a stimulus in order to balance out that kind of those internal conditions, right? So think about a balance beam. Your body always wants to be balanced. So the body maintains what we call homeostasis through feedback loops. And this is essentially a series of like stimuli that tell your body like, hey, you need to warm up, or you're too hot, too cold, whatever. If we're talking about the temperature, at least. Okay, so there are two types of feedback loops. There's negative and positive feedback loops. And some terms to know are, first of all, stimulus. So a variable that will cause a response is a stimulus. So anything that causes a response is a stimulus. A receptor or sensor, and that could be a sensory organ that detects a stimulus. So when we're talking about cell-to-cell communication, for example, there were the receptors that detected the hormones in at least the longer feedback, or not longer feedback, long distance signaling. So this information is sent to the control center or the brain, and then there is effectors, right? So muscles or glands that will respond as a result of this receptor finding that stimulus. And then a response is obviously the changes that the decrease or increase, which is the effect of the stimulus. So the changes in your body in response to the stimulus. All right, negative feedback. So these are pretty easy to grasp, in my opinion. So the most common feedback mechanism is actually negative feedback. And this type of feedback will reduce the effects of the stimulus. So, for example, sweating, blood sugar, and breathing rate. What I mean is sweating will reduce the heat. So you'll sweat because of heat. You want to lose heat. Blood sugar, breathing rate, you want to like lower your breathing rate, for example. So I'll give you a more specific example of negative feedback in just a second. So this type of feedback reduces the effect of the stimulus. All right. So an example is body temperature regulation. So this is Patrick. He should be pretty familiar to you. So Happy Patrick has a good body temperature. So he's within the range of 97 to 99 degrees Fahrenheit. He's a Happy Patrick. All right. So there might be a stimulus, however, that is heat. So the stimulus would be heat, and the receptor would be the temperature receptors in the skin. The effector would be the sweat glands, and the response is to sweat, right? So sweaty Patrick might, he might be like too hot. So he, the receptors in his skin kind of detect that he's hot. And then his sweat glands start to reduce that temperature by sweating. Okay. On the other hand, if he is cold, the receptor would be the temperature receptors in the skin. The effector would be the muscles, and the response would be to shiver. So he's reducing the stimulus, the coldness, by shivering, those muscles contracting and producing heat. So we have shivering Patrick, and eventually, hopefully, he'll go back to happy Patrick. Okay. So once again, negative feedback loops or negative feedback mechanisms is where there is a stimulus, so heat or cold in this instance, and we are trying to decrease the effects of that stimulus. Okay, so if we're too cold, we want to decrease that coldness. So we want to warm up. If we're too hot, we want to decrease that heat and sweat out all of that heat. All right, through evaporative cooling. All right, positive feedback is obviously the opposite of this. So this type of feedback increases the effect of a stimulus. Examples are going to be child labor, which we'll look into a little bit more in just a second. Blood clotting, fruit ripening. So you might not want to put your fruits next to each other, and we'll talk about why. Okay, so in childbirth, the stimulus is the baby pushing on a cervix. So we want to increase that because obviously, if the baby is ready to go and he's pushing on the cervix, then you want to increase the likelihood that he gets out because that's kind of the point of childbirth, right? So the receptors are the nerve cells in the cervix. They send a signal to the brain that says, "Hey, baby needs to come." The effector will be the pituitary gland that releases oxytocin, and oxytocin will stimulate contraction. So it starts, the contractions, which lead to a dilated cervix. And then eventually, once that is dilated enough, I think it's 10 centimeters, we have a baby, right? So then your stimulus, goes back to the stimulus, and the cervix starts to dilate. And that's what contractions are, is the dilation of the cervix for childbirth. Okay. So positive feedback loops are increasing the effect of the stimulus, right? So we want to have that baby. So that pituitary gland is going to be activated and release the oxytocin that increases the effect of the baby pushing on the cervix. All right, homeostatic imbalances. So there's a lot of reasons why the body may not be able to regulate homeostasis. For example, there might be a disorder that decreases the ability for you to regulate whatever it is that you need to regulate. Drug or alcohol abuse. Obviously, drugs and alcohol can bind to receptors that they're not supposed to, and that can decrease the effect of different, feedback loops. Intolerable conditions. So, for example, if you hop on up to Mount Everest and I don't know, you don't have enough clothes on, I don't know. So, extreme heat or extreme cold, for example. Or another thing would be just drinking 10 gallons of water at once, right? So that water imbalance is intolerable. So intolerable conditions can't be mended easily or at all, even. So that would put a damper on your homeostasis and your feedback loops. Okay, disease is another one. So when a body is unable to maintain homeostasis, or not is another one, but when a body is unable to maintain homeostasis in general, that is disease. So examples are cancer. The body cannot regulate cell growth. So what cancer is essentially is your cells kind of go out of whack. They divide uncontrollably. And that's how you get tumors is the uncontrollable division of these cells. Diabetes, we've said before, the body cannot regulate blood glucose levels, so you might have to, inject artificial insulin, right? And that will regulate it artificially, but your body can't do it for you, essentially. Right. And then cell signaling is a means of homeostasis. So, in order to maintain homeostasis, the cells in a multicellular organism must be able to communicate with one another, which we've gone through those, right? They are signal transduction pathways. So, your body uses those signal transduction pathways to consistently try to maintain homeostasis. Okay. So, that's kind of how those all relate to one another. All right, and that is all of your notes for today. So make sure that you watch that blood glucose video and answer those questions as soon as you're done with these notes. All right, I'll see you guys tomorrow.